All right, so today is basically completing the square when a isn't 1. So you are going to have a value in for a, so we have a little bit more work to do than what we did yesterday. Same thing is that we are going to isolate the variable on the left, and then we are going to factor out the greatest common factor. So this is what is new today, is that we are going to factor out the greatest common integer, not the variable. So what we want to do is we want to take, if it is ax squared plus ax, we are just going to factor out the a and leave the x. Okay, that's what we're talking about. Is that we're taking out the a, but we're going to leave the variable. Then we're going to complete the square just like we did yesterday and divide both sides. And then we're going to take on these two steps, divide both sides by this a value. Okay, so we have our a value and our b value and our c values over here. So what I want to do is take out this a value. So I want to factor that out. So I'm going to bring that 2 out in front, and I'm left with I'm left with x squared plus 6x. And then I'm going to close the parentheses and have 14 over here. So all I did is I took a 2 out of here and I took a 2 out of here. And I'm not touching the 14. So all I'm doing is factoring out the integer. Same thing as I did yesterday is now I'm going to take this b value and I'm going to take this 6 divided by 2 and then square it. So the same process, which will be 3 and then squared, which would give us 9. So the 9, I'm going to add 9 in here. Really what's happening is that this 9 is getting multiplied by this 2. So I do need to add 9 over here. I do have to add the 9 over here. But since this 9 is really getting multiplied to this 2, I also have to put this 2 times this 9 over here. And that is balancing out the graph, or balancing out the equation. Since I added 9, and it's be multiplied by 2, if I distribute this in, I also had to put 9 times 2 on this side. Okay, so same thing. So still adding the 9 to both sides, but this time is whatever I factored out also has to be multiplied to it on the right-hand side. Then I'm going to simplify the left-hand side. So I still have this 2 out in front. Just like yesterday, this 3 gets to come right here. So it's just going to be x, and it's a positive 3 squared. And then I'm going to take all of these numbers right here. 14 plus 9 times 2. And 9 times 2 is 18. Add to 14, we get 32. Okay, and that's where we get this 32 from, is all those numbers right there. And then this 2 is coming down from right here. So a lot's happening. And now this is what we did on Wednesday, is we are just going to take this equation and now just solve. So divide both sides by 2. And we have x plus 3 squared is equal to 16. I'm going to take this up here. And before I do that, I'm going to square root both sides. So what I get out is x plus 3 is equal to, and 16 is perfect, so that's going to be plus or minus 4. And since there's no radical, like I talked about on Wednesday, we can split it up into our two answers, which is x plus 3 is equal to positive 4, and x plus 3 is equal to negative 4. And we just go ahead and solve. So remember, here's the positive 4s right here, and the negative 4s right here. Subtract 3 to both sides, and I get x is equal to 1. Subtract 3 to both sides over here, and I get x is equal to negative 7. So since I don't have, this 4 is not underneath the radical, I split it up into 2, and then I solve, and I get my final two answers. So let's recap. I take out an integer between our a and b value. So I take that integer out. Now my new b, which is 6 after taking the 2 out, is I do what I did yesterday. I take 6, I divide it by 2, I square it. I get 3 squared, which is 9. I add 9 inside the parentheses. And I also add 9 on the other side of the equal sign, but now I also have to multiply it by the 2, which is out in front that I've already factored out. Then I just go through the whole process as I did yesterday. Here comes that 3 down here in this little spot right there, because that's the number before I square it. The 2 comes down, and then the 4 times 9 times 2 all turns into the 32. And then what we did Wednesday is we solve this and we get our 2 answers out. All right, so let's go ahead and try another problem. So this problem is just written on the other side. So I have 63 is equal to 3x squared plus 12. So if I take out a 3, I'm left with x squared. And if I take a 3 from 12, I get plus 4x. And then I'm going to leave some room and close off the parentheses. So again, I'm going to take that 4, which is my new b. So 4 divided by 2. And then I'm going to square it. So 4 divided by 2 is 2. And then square it, I get 4. So I'm going to add 4 in here. I'm going to add 4 over here. But I also have to remember that that 3 that I multiplied or that I factored out also needs to go over there as well. So now we are going to simplify this equation. So since this is over here on the left-hand side, what is 3 times 4 plus 63? That's going to go on this side, which is going to be 75. Is equal to, I still have that 3 out in front. And then I have x, and that number before I square it is going to go right here. And then squared. So the 2 is the number before I square it, and that's going to go here, just like we did last week, or yesterday. So now I have this problem, just like before. I now need to get x by itself, so I can divide both sides by 3 from this 3. And 75 divided by 3 is going to be 25, is equal to x plus 2, and that's squared. Now I can square root both sides. And I'm going to take this up here. And the square root of 25 is plus or minus 5, which is equal to x minus 2, plus 2. Since 5 is a perfect number, we're going to split it up into our 2 factors, or to our 2 numbers. So it's I have 5 is equal to x plus 2, and I have negative 5 is equal to x plus 2. Make that look more like an equal sign. And now I can solve. So I'm going to subtract 2 to both sides, and I get x is equal to 3. I'm going to subtract 2 to both sides here, and that's going to be negative 8 is equal to x. And those are my final 2 answers. So there we go. Again, we need to factor out that integer, and then we take that new b value, divide it by 2, square it, and put it on both sides. But don't forget the other side, not only do I add the 4, but I also have to multiply by the 3, because really this is 3 times 4 right here. So I need to make sure it's 3 times 4 over here on the left-hand side. So don't forget, if you factor out a number, it has to be multiplied over there on the left-hand side. All right, the next 2, we have another step before we can go forward. So before, we had that c value over on the right-hand side. So we got to move this 48 over. Let's move the 48 over. And then let's also take out that 4. So if I take out this 4 right here, so if I take, let me do it in a different color. So if I factor out this 4, if I divide this by 4 and that 16 by 4, that 4 is going to come out in front. I'm left with x squared, and 16 divided by 4 is 4x. And then I'm going to leave some space, and then this 48 goes away on this hand side, and I'm left with equals 0 plus 48 is 48. So I kind of did all one step. I moved over and I factored out that 4. Now that I factored out the 4, I can take this new b value, which is 4, divided by 2, and square it. 4 divided by 2 is 2. Squared is 4. So I'm going to add 4 in here. I'm going to add 4 over here on the right-hand side, but I also need to multiply it by this 4 as well. So this 4 times this 4, and I need to multiply that 4 over here as well. So I still have the 4 out in front, x, and then I have this 2, which is a positive 2, goes right here, squared is equal to 48 plus 4 times 4. All of that is going to equal 64. And then we go through the process. Now that I have it in completed form, I now can solve. Divide by 4 to both sides. X plus 2 squared is equal to 16. Square root both sides. We get x plus 2 is equal to plus or minus 4. And then we can write those two separate equation is x plus 2 is equal to 4, and x plus 2 is equal to negative 4. Solving, I'm going to subtract 2 to both sides, and I get x is equal to 2. Subtract 2 to both sides over here, and I get x is equal to negative 6. And again, we put it in a perfect square, right? Perfect square trinomial. Then we can write it this way and solve. So really what we're doing from Wednesday and Thursday is that, right, we're making this turn into something that we can solve and we know what we're doing. So this is what we did Wednesday, is solving. All right, our very last one, again, I'm going to kind of do a couple steps in one. I need to move the 27 over. So I'm going to subtract the 27, and then I'm going to factor out this 3. So when I factor out the 3 comes out in front. I'm left with x squared, and then negative 24x divided by 3 is negative 8x. I'm going to leave a big blank, is equal to, and then I got that negative 27 over here on the right-hand side. So that goes away, and I have negative 27 over there. I'm going to take this negative 8. So don't forget it's negative 8. So negative 8 divided by 2 and square. That's going to give me negative 4 squared, which is 16. I'm going to add 16 in here. I'm going to add 16 over here on the right-hand side. But again, remember, I'm multiplying this 3 to this 16, so I need to multiply this 16 by a 3 as well. Simplified in a completed squared form, that's going to be the 3 comes down, the x, and then remember, this is a negative 4 before I squared it, so it's going to be minus 4 squared. Right, that's what's going right here. And then what is negative 27 plus 16 times 3? Negative 27 plus 16 times 3, that is going to give us 75. And then we know what to do from here. We go ahead and solve. We take that 3 and we divide both sides. And so we get x minus 4 squared. Glitching right now. Is equal to 25. Square root both sides. Up here we have x minus 4 is equal to plus or minus 5. And then we just break it into our two parts. We have x minus 4 is equal to 5, and x minus 4 is equal to negative 5. I'll add 4 to this 5, and I get x is equal to 9. I'm going to add this 4 to negative 5, and I get x is equal to negative 1. And those are our two answers. And you have now solved quadratics by completing the square.